Cool. So this session is the WebSocket perspectives, past, present, and future, the state of the stateful. And that's me, Frank, and I'm from the New York area, so I'm glad to see this really beautiful weather here. And I'm going to talk about WebSocket, past, present, future, and then I'll hand over everything to Kevin to show you some really, really cool WebSocket demos. And I guess we'll leave Q&A for the end. And I guess we have nobody after us, so if you have additional questions and stuff, we can keep on going for a while. So the basic meme for my presentation is just to realize that like history repeats itself. And we can't often predict when waves happen, but when things happen, we can almost predict the evolution of that meme. And it just happens not just in computer science, but it's happened through many aspects of our lives. So this is what I wanted to focus on for this presentation. So let's start in the beginning. I'm going to just devote the first 10 minutes on the past and the present, since it's probably of historical value and some interest, but it's really where we're going that's the most important. So I added this picture, this probably the first cloud system, for no reason, but I thought it was cool. I mean, here's his 19,000 tubes. This guy's changing a tube in one of the first computers. I guess a little. How many transistors does a i7 have? Like 2 billion. So from 19,000 circuits to 2 billion. Anyway, so going back to the beginnings of enterprise distributed computing. So for about a decade and a half, we did a lot of distributed computing inside the firewall with familiar TCP applications, TCP protocols. And we were doing things like Corba and RPC. TCP was even older way back when. So I mean, how many people remember things like Corba and RPC? Probably a few of you do. And you remember how lovely those technologies were to work with and why they're not around anymore, or hardly around. So we learned a lot of lessons about what worked and what didn't work. You know, the old RPC and Corba request response just didn't work. It didn't work in the enterprise. And I'll talk about that a little bit later, what replaced it. And then later on, after the early 90s, certainly HTTP came out in '88, I think, if I remember my hypertext history. And up until 2011, and it's a key year, which you'll see in a second. So we went over the firewall with HTTP, and we connected through an app server, a web server, using traditional TCP stuff in the back. And 9 times out of 10, or probably 99 times out of 100, it was a database behind us, right? And I remember my first app server systems, the big complaint from users was always performance. And performance was always the database, right? So that was a big problem back then. And to do things like simulated notification systems, simulated real-time, HTTP wasn't really suited for that. So we came up with some lovable hacks, right? Ajax and Comet were hacks that were basically simulations of real-time. And we don't need them anymore. So they served their purpose, and our hats are off to the people that invented those things. So here comes WebSocket. And now how many people know about WebSocket? Cool. It's like 90% of the audience. It's very, very cool. So we know that WebSocket has two components. There's an API and there's a protocol, right? So the IETF guys, they govern, they're the HTTP guys. They govern the bits over the wire. That's a standard as of 2011. So you guys know that on the web, there's now two major protocols. There's HTTP and there's WebSocket. So there's not just HTTP, there's two. And they both sit on top of TCP. And also the W3C has a standard for a JavaScript API. So there's two standards. Remember, WebSocket is not just one. It's not just an API and it's not just a protocol. It's two components to it. So it allows you to do event-driven things. Like most of the things in the world are event-driven. So this allows you to have event-driven, or allows you to build event-driven systems using WebSocket. But also note that the W3C specifies JavaScript only. It's a single connection, and it's a full duplex connection. If you remember your computer science, full duplex means it's a single pipe and bi-directional at the same time, as opposed to having two connections like Ajax and Comet was 2 connections, 1 up and 1 down to simulate real time. So thankfully we're past that. And the URL, as you would imagine, the URI is ws://, and as you would expect, WSS is what? Secure WebSocket, exactly. TLS/SSL. And its purpose is to traverse firewalls, and you could send text and you could send binary. I mean, originally it started off text, back in between 07 and 08. 08 was a bad year. Between 07 and 2010, it was just text, and thankfully they added binary. So what WebSocket is really good for, it's good for building event-based systems, which essentially are most of the systems on the planet, right? And if you, I guess the trendy term is reactive systems. I mean, people have been dealing with this for years. It's not exactly a new thing. It's just cool to call it reactive systems. And if you want to do a little research, look up ECA systems, which come from distributed database, object databases way back when. Event condition action, which is the basis of all this stuff. So for doing event-based things, there's no question. Once you see a WebSocket application, you can see a WebSocket application, some demos are at our booth, but once you see the speed that you can do with WebSocket for event-based applications, you can't go back using something like Comet or Ajax. It's supported by older browsers, older modern browsers. Obviously, older browsers don't have WebSocket. But all the modern browsers do. Even IE, the latest IE, has WebSocket. Effectively, it's an application-level socket over the web. So think of it as sort of like a socket. It's not really a socket since it's on top of TCP, but it's effectively an application-level socket. So which means, since it's a stream-based mechanism, you can sit other protocols on top of WebSocket. So you may see an article on WebSocket out there. Somebody's going to write a hello world of WebSocket, and here's how you learn it. You build a hello world system or some simple pub sub chat system. It's really, maybe do that to learn it, but in practice and in production, you're never going to do that, right? How many people program at the TCP layer anymore? Nobody does. I think people did that like 60 years ago. They did it for a week, and they said, like, this sucks because there's no protocol, right? So the next day, application protocols were invented. So if you take this concept of taking WebSocket and layering things on top of WebSocket, so you're not programming at the WebSocket layer, you can now write applications faster. Obviously, there's an abstraction for us, right? So it's certainly a lot faster. And it also means that you can now connect to existing systems, since most things inside the firewall are real time. And we know that enterprise real time, it's not real time like a nuclear reactor. It's real time just means event-based. Right? So it's taking those same event-based systems inside the firewall and now taking them over the firewall, which is, finally, we have client-server over the web like we had 20 years ago. So that's the past and that's the present. Now, what's next for WebSocket if you take these concepts in mind? So we know that the latest, one of the trends that's happening right now is the Internet of Things. Right? We have Internet and we have things. We're trying to pair them together. But also, besides the Internet of Things, where does the web fit, right? So let's take a look at that. So what are the event-based systems on the planet? Well, if you think about it, everything is event-based, right? Everything that we do is event-based. There's very little that's really not real-time, and again, in quotes, real-time. So really, what does this have to do with the web? Oops, sorry. So let's just take a microsecond to go back in time just a little bit, or not in time, but in terms of definitions. Remember that the internet, what the internet was, it's short for internetworking. It's connecting networks together. That's the internet. I remember 2 weeks ago, a marketing guy came up to me. He said, I came up with this term, Internet of Clouds. I said, no, that's the internet. So it's a collection of different networks. That's what the internet is. So what's the web? The web is a popular service on the internet, and we all know that, right? We're all super techs here. It's only one service on the internet. Let's see, I think in terms of bandwidth, it's about 9% of internet traffic. I think Netflix still is like 30% of bandwidth on the internet, and of course there's Pandora and there's other protocols. And probably of that 9–10% of web traffic, half of that is for visible, for eyeballs, and half of it is for plumbing, right? And you guys probably know this. Maybe your mother or father don't know that. You'll always see a browser, but half of the web is hidden, right? There's the plumbing aspect of the web, and probably mostly net robots. But what's the advantages? What are the advantages of web? Okay, we've learned that deployment is ultra simple, right? All the managers on the planet, when the web came along in the mid-90s, they said, I can now deploy applications by giving somebody URI, right? And I'm done. That was like phenomenal. So we have instant deployment. We have all kinds of open standards and specs. It makes it easy for all of us to do programming, whether it's in JavaScript or another scripting language. It allows us to leverage economies of scale. There's all kinds of benefits for using the web. And again, there's two protocols for the web. Now, that's our step back. Now to go forward, so we have Internet of Things. Some companies are calling the industrial IoT. I mean, it's a semantic game, right? Whether it's IoT or Internet or industrial IoT. Basically, devices imbued with IP intelligence, right? Connected M2M. And this stuff has been around for ages, I mean, decades. And traditionally, it's been proprietary systems all using some form of RPC, right? Remote procedure call. Remote procedure call is request response, right? And which certainly was popular in the 80s. So that's what IoT is. The problem with IoT is that it's just connectivity, right? Just like when we had the internet and we didn't have the web, we had connectivity, but we needed more. So now with having IoT, there are no formal standards for APIs, for programmability. There's too many protocol standards, right? If you go out and look at all the M2M systems, there's dozens of different protocols. There's no common frameworks. You can't create super services together. You can't create new services out of a collection of smaller services, no composition. And you can't have economies of scale. There's a lot of barriers to the existing IoT. And also, we have to take whatever technology we build with IoT has to be in a world where we're in a cloud, mobile, and web API world. Anything we build has to have that in mind, right? That's pretty clear. So here's where the web comes in. So we have IoT. So the web of things is a layer on top of IoT. And what does it give us? Well, it gives us the same benefits that the web gave the internet, right? It gives us developer access, additional standards. It makes it easier to deploy applications. It gives us all the benefits that the web gave the internet. It just makes it so much easier. Now, certainly there'll be other IoT systems that don't use the web, right? It's not an answer for everything. It's an answer for a lot of things. But it's the benefit of giving us a higher level API. Because in the M2M world, there may be hundreds of developers, but the world needs millions of developers in the IoT space, right? It needs all of you guys to build cool apps, right? We can't do it with the existing M2M APIs because there's a lot of expertise that you need, and not everybody can understand that expertise. It's very parochial. But if you had the web, all of you now can program for IoT. This is a very, very cool thing. The issue is HTTP the right choice? Right, because we go through time and technologies get tweaked, right? We dealt with HTTP for now 25 years. So now we're in this new world of Internet of Things, connected devices. We have HTTP for things, but is that the right choice? So, I mean, we learned a lot about the deficiencies of RPC inside of the enterprise. So maybe it's not quite the right thing to use. It's a little brittle. I mean, we've learned that RPC was brittle, and HTTP is a form of RPC. HTTP is sending around a lot of metadata, right? Along with the data, you send metadata. And in a document-centric world, the data overwhelmed the metadata, so it was fine. But in an IoT world, the metadata is going to overwhelm the data, because typically the data is small, and the metadata would be big. So is that the right technology to use? Maybe not. So we need to look at other alternative mechanisms, and perhaps HTTP is not the right thing. again, as I said from my first slide, history often repeats itself, and sometimes you can predict the future by looking back 10 years, right? Because typically, you look back 10 years, sometimes something was a cool idea, but it didn't work out because the technology wasn't ready, it wasn't mature, and then somebody comes along and tweaks it, makes it more convenient. An example is like Twitter, right? That's basically paging from 10 years before that. It was more convenient. So it used modern technologies to make it convenient. And we've learned that you don't have to have a boil the ocean type of idea to make it be successful. It can just make it convenient for users. People will use it, right? People forget that. So let's look what happened in the enterprise. We started off with RPC, point to point, and then the first thing someone said, like, well, I'm waiting for a calculation and my application's blocked. So what do? Well, we need some sort of asynchronous RPC. In other words, call me back when you get the answer, right? When the calculation is done, call me back. So then async RPC was added. And it still was a problem, right? Because you have like Node A was talking to Node B for data, and then Node A would be talking to Node C for data, then Node C would be talking to Node B. Now multiply that by hundreds of nodes inside of an enterprise, or maybe thousands of nodes. It became a combinatorial problem. So the solution for that was an enterprise service bus, right? A message bus. So how many people know about message buses? That solved the problem. And it was a little bit harder to program, right? It wasn't as easy as like, oh, I'm connecting there to there, I'm done. It was a little more difficult, but it provided manageability of distributed computing. It was just easier to connect to things that weren't available, right? We have publish and subscribe. It solved a lot of problems. We still had RPC, but the use for RPC just went down and down and down. It was messaging was the way to go. Let's look at today. So we have REST, right? We have REST. People are asking like, I don't want to wait for that calculation or that database access. I want to be called back. Give me a future so I can know when it's done. So asynchronous REST. Well, it looks very familiar to what happened inside the enterprise. So what I think is going to happen next is that because of the same issues that we saw 10, 15 years ago, we're going to solve it in the same way. It seems like there's really nothing really new in computer science. So I think this is going to happen also with the web and the IoT. That we're going to have some sort of messaging, whether it's pub sub or some variant of pub sub or lightweight pub sub. I don't know. That's for you guys to come up with. But it's going to be some sort of messaging. It just reduces the complexity for development. And we already see people that have written about this, how the next generation of devices, of intelligent connected devices, you just can't use RPC. It's just, you can't use these point-to-point systems. Like in the enterprise, it's a combinatorial problem. And for status, for querying, it's just, it's the wrong approach. So this was an interesting book that I found. The author, Francis DaCosta, was talking about messaging, or he mentioned specifically publish, subscribe was the way to go for IoT. So let's look at the differences between traditional web and, in other words, eyeball web and non-eyeball web. So with eyeball web, we have a lot of data that's being sent from the server to the client, to the browser. There's a large data, small metadata over to the browser. So let's look at IoT, or web of things. We have small devices, right? And the data set is small. It might be very frequent, but the data set is small, and it's going to the server. So if you think about it, eyeball web was designed, and we had web servers and app servers. That was the correct approach. So now we have a different use case, right? With small data and a lot of devices. We're talking, millions, billions, and then there's a recent conference talking about trillions of devices soon. It's a different use case, right? So maybe a different architecture is needed. Yes, you can use traditional architecture, but will that scale? Is that the right approach for Internet of Things? So, like everything else in our world, what solves a problem with architecture? Right? It's been true for 60, 70 years. Like architecture is the answer to this. So maybe, and this is my thoughts on this, and you might have a different approach. But if you have a collection of aggregators or these event gateways like I'm talking about this slide, where you have the things in blue are more native IoT. Those are things that can't use the web for various reasons, or they're not in a web-friendly world. So they're connected to some sort of event gateway that knows about WebSocket, right? And the ones to the lower left here are web-enabled. So the orange is web-enabled. So you have a collection of event gateways together. So perhaps in the future, to connect millions of devices, we need a different type of architecture. We can't use a simple case of a web server or a collection farm of app servers. It might not be the right approach for devices where the use case is different. So by using this type of architecture, you get different types of, you get a better querying model, because you don't want to query 1 billion devices for status, right? It's pretty clear. You want to have these aggregator nodes query the devices, or maybe query their aggregators. And then your query obviously is a lot faster, more optimal. And it certainly improves performance. And it allows you to compose higher level services. Because if all this is more stream-based, and you have the aggregator nodes knowing about the data, you can now build things, super services, by connecting to these aggregator nodes. And it allows you to have a different type of security model. Because what's our security model now? It's firewall-based. Does that fit Internet of Things? Does the firewall model fit the Internet of Things? I don't know. Maybe it does, maybe it doesn't. But now we're talking about like millions of devices. It might not be the right model. So we might have to develop these circles of trust, or I guess ellipses of trust in my diagram, with circles of trust, where there might be one circle in the bottom and another circle someplace else, but they trust only within that circle, and there may be multiple circles. Maybe that's a different model than having a single type of security thing, a firewall. Maybe that's a better approach. And if you do this, this is very similar to a CDN, right? And the CDN is great for what? For static data. That's their ticket to fame, right? It's just they're very good at caching, and they're good for HTTP type of document-centric things. But are they good for real time? They're not. CDNs are not good for real time. And in the future, we want to do more real time stuff. So these are directions for WebSocket, and it's just for our company, for you guys to build things that use WebSocket in a different way, so that it's more applicable to the Internet of Things. So I'm going to turn everything over to Kevin, but anyone have any quick questions before I do that? Just crickets? If you have a question, there's a mic there. How many people are doing IoT development? Okay, a few in the back. Actually, it's an excellent question, and I think if you hold that question, yeah. I'm sorry, I didn't hear it in the back. So the question was on battery for mobile devices. Isn't WebSocket, which is a persistent connection, isn't that bad for the battery? Actually, we'll get to that in a second, but the quick answer is that actually it's better for the battery, because it's maintaining a connection as opposed to going from a high energy state to a lower energy state, constantly doing this, which is bad for the battery. It leaves it at one state, which is much, much better. But we'll get to that a little bit later. Any other questions? So the question is, do we have use cases for Web of Things? Well, I think I had. This is going to be great on a recording. Okay, so my really poor animation here. All these devices. all these applications are perfect use cases for Web of Things. Is that the question? So so working use cases, I think, as I'm now turning everything over to Kevin to show you demos of that, I think that you'll get your question answered right away. Any other quick questions before? Okay.
Knocking over water onto electronics, not good.
Water electronics.
All right, thanks for your patience on the juggle here. This is a not working, is what it is. Fairy dust, anybody? No? Oh, hello. Dang. That is really, really, really small on my screen. All right, hold on. No, that's not the one I wanted. Scale that bad boy. Sure. Let's try 720. Oh, that's much better. Okay. So, all right. So my name is Kevin Hoyt, and I'm a principal evangelist with Kaazing. I get to pick up after Frank, and he was leaving off kind of this Internet of Things, and I think that's a very fascinating area. I spent a little over a decade, about 13 years at Adobe, and I got to do all kinds of really cool things with makers and people who are creating gadgets and UIs for gadgets, and it's really been a passion of mine. And I think what's one of the interesting things in the Internet of Things is that there is often, in many cases in the Internet of Things, there is no UI proper, which introduces its own set of challenges, but specifically I think that's where HTML5 or the web in general becomes a great UI for all these disconnected things, right? Your Fitbit, for example, has a very minimal UI. It doesn't have this big glossy screen with all this kind of crazy stuff on it because it would kill the battery. You know, the Nest has a very little screen on it. So when you think about bigger picture, being able to see charts of the data that's going on with those devices, being able to, from a historical perspective, or control them from a historical perspective, or from moving forward perspective, I think web is a great way to go. So as for UI. So in this case, I'll refer to Arduino, which is kind of my platform of choice, at least for these. Ended up being my platform of choice for these particular examples. But I think Arduino, or hardware in general, when coupled with a web-based UI, equals unicorns, really. Which is kind of another way of saying it's win. It's full of win. I love that the horn is bacon, frankly. Bacon. That's going to lead with bacon. All right. So, so hardware and web is all win, and it's a great opportunity if you haven't already kind of started playing around with that space. I saw a few hands raised on the IoT bit. It's a great place to go. I'm going to show you a few different demonstrations today. The first one I'm going to show is actually one I call clean water. And the idea behind clean water is to be able to pour water from one screen to the other. And the bigger from an IoT perspective here is that sometimes we forget that this is an internet connected thing, right? This is a really, really powerful internet connected thing at that. So don't forego the opportunity to play with the Internet of Things. If you have hardware, GPS, you have cell data, you have accelerometer in here, you have all kinds of really cool things you can pick up on and do stuff with. So don't forget the hardware that you have in hand. There is the UI display, and my screen, of course, is here, so it's going to look a little weird because it'll be backwards for you. But I'm going to go ahead and scan that QR code, which is going to take me to a URL, which in this case, I know is very difficult to see from all those seats, but it was a similar thing, but on my phone, and there's a little bit of water level, and as I tilt my phone, that water level reacts. And that's just happening to use the accelerometer based on the device. And I know the screen dimensions of the device, so with a little math, I can figure out where the corner of the device is, and if that water meets the corner of the device, I want to pour water from the edge of my cup, if you will, into the other screen. All right. So pour a little bit more. It's actually responding really finicky right now. I don't know why that is, but so you get the idea. So what's happening here is we have a WebSocket exchange from one device, that's this guy, doing mathematics and client work for its user interface, and then deciding what to do with that data, and in this case, sending it to a different client UI. And in case, if anybody actually in the room who was looking at this website could actually then see that getting poured on their screen. So WebSockets brings some really cool kind of interesting capabilities. This is actually a proof of concept I did for an agency. It was looking for new and different ways to encourage people to donate money for the purposes of clean water in third world countries. So you know, WebSocket to the rescue for new and interesting ways to do real-time stuff. And again, don't forget that your phone is functionally an internet thing. So moving along then, I'm going to start talking about this guy a little bit more. This is an Arduino Yoon. If you haven't heard of the Yoon, I'm not even sure, entirely sure I'm pronouncing it correctly. But the Arduino Yoon is an Arduino, but it has two parts to it. Now, if you're not familiar with Arduino, how many people here are familiar with Arduino? Fantastic. So I won't go through all this. You guys know that it's not mega controller. It's got 16 powerful megahertz to do stuff with. It's open source, programmable via USB, but the Yoon brings a whole other side to that equation, which is an Atheros AR9331, which is effectively a Linux system on a chip. So that big shiny bit in there that says Yoon, that's actually the Linux system on a chip, and it has Wi-Fi built in, it has an Ethernet port built in. The USB on the front isn't, there's the micro for programming, but the big one next to it is actually a receiver for USB, so you can use that as input to control various reactions on the coming off of the Arduino. It has an SD card reader for the actual drive, if you will. It includes 64 megabit of RAM, but RAM isn't really good for recurring read-write in this particular configuration, so you try to use a separate SD card for that where you can dispose it, because in this configuration, if your RAM burns out of read-write, your card is toast. So you put that on a little SD card, and then you have a lot more space to play with, right? Put Apache on there, PHP, something like Mongo or Node or whatever the case may be. So that's actually the platform that I'll be using. I'm using it because it's Arduino for one, and two, I'm using it for the fact that it is internet connected. And that's where things get sketchy in this demo, so hopefully things go right. We will soon find out. The next thing I think that I'll talk about here is this guy. So this is a heart rate monitor chip. That's the big kind of blocky thing on this side of the screen is heart rate monitor from Polar. So if you ever exercise, you were going for a run or a bike ride or whatever, you wear like one of those chest straps. Now I have one of those on right now, and I'm actually going to broadcast my heart rate over WebSocket thanks to the Arduino Yoon. So that's what I'm wearing, is a Polar T31. It's really uncomfortable, by the way. I don't like to wear it throughout the day. I wouldn't recommend this model. It's not the model I exercise with, actually, because it's got that big long strip of plastic which just digs into your skin. But it was the one that I had on hand for purposes of this demonstration. So I built the demonstration. In this case, I call it Hermie, because things in the hardware world have to have cool names. So this is Hermie in a very raw form. This is the heart rate monitor, the Arduino Yoon, and I'm just going to drop it down here and plug it in for battery. Okay. So the last time I think I gave this, I was running it off of a 9 volts. But this one, I'm going to run off of my computer, just for the purposes of the battery. So what's going to happen is that the Yoon is going to, if I've done everything right, is going to log on to my wireless, which is great. It's going to sample the heart rate from that Polar chip. It's going to use a protocol called Stomp. Stomp is a simple text-oriented message protocol. It's very easy to use and implement. There are a lot of libraries and implementations for it. You can write your own. I wrote one for Arduino Yoon, and it's going to spit the data coming off of the heart rate monitor into an ActiveMQ instance running in the cloud, and that is then going to distribute it via the Kaazing gateway actually to all the different clients that might be watching in this case. The rendering is happening through SVG because it's easier to draw charts with SVG. It's very clean, especially if I'm working across multiple devices where I want to have responsiveness, for example. I use Tweenlight to animate the SVG versus actually SVG animation. And that's because it's a little easier to use from a functionality standpoint. And then that whole thing repeats every second. So let's see if it is indeed working. It has a very short range. So 0, oh, there we go. I'm dead. So this is my heart rate again, and a little high right now. Last time I gave it, it was like 90. So anyway, that's because I'm nervous whether or not the wireless is actually going to work. So again, that's happening as the beats come across. You can see the drawing on the beats per minute due to the screen resolution, but yeah, there's a bug to be fixed. But anyway. There's my heart rate. Now you can think about this from kind of a medical perspective, an IoT perspective, and a web perspective. I don't want to see this tomorrow, right? If you look at a Fitbit is, in my opinion, kind of a worthless IoT device. I mean, it may be kind of motivational temporarily, but in the long term, because it's just a batch system, I don't really get to see that I walked 10,000 steps or not until after I did or didn't do it. What I really need is something to be real time. I need it to be bi-directional. I need it to be able to tell me, get off your lazy butt and go walk around the block. I need that nudge, right? I need it to be connected, and I need it to be real time, right? And that's just a Fitbit. But you think about, in the kind of IoT aspect, monitoring your patients, right? There are 300 million Americans in the world. If all of them are wearing some sort of heart rate monitor for their physicians, for example, not that that's going to, or 300 million Americans, if all of them are going to be wearing a heart rate monitor, not that they're going to do that, but if they are, think about how your infrastructure has to deal with that. And your physician doesn't want to know an hour from now that you're having a cardiac distress moment, okay? So these are the types of the cases where WebSocket and the web as a UI can work really well together for real-time data. So there's my heart rate, or as I like to call him, Hermie. I built a laser cut little heart enclosure that I clip onto my belt usually, but I didn't bring it today. So the next project so I showed you two different projects. I showed you using your phone, which is the hardware you have on hand. And the next thing I've talked to is about using a heart rate monitor with an Arduino Yoon. I suppose now I probably should have done some jumping jacks or something. Anyway, the next project I'm going to show you is also designed. All of these, by the way, if you're looking at the web browser where these are positioned, you'll see all this data in real time. And in this case, hopefully, maybe, you'll actually participate as well. So I'm going to unplug Hermie here. So this is an Adafruit NeoPixel. NeoPixels are really cool. They're RGB LEDs, which stands for red, green, and blue. LED, which stands for light emitting diode. All put into one little tiny package. And the cool thing about that is if you look at this, if you have R, G, and B, what can you make? You can make different colors, right? The colors you might want to sample from the web or sample from the real world or what have you. So there are effectively 3 little tiny lights in here, one for red, one for green, one for blue, and you can control the brightness of one or the other to say whether it's 0 or 255. So Adafruit provides these, and I like these ones. There are a lot of different RGB LEDs out there. These ones I like because they're really easily chainable. You can see the wires come in, they go around to the next one, they go around to the next one, they go to the next one. If you do any kind of, if you're trying to do any kind of RGB LED straight up, like the actual little units with 4 legs coming off of them, 3 or 4 legs depending on what you're trying to do, those guys, right, then you end up with this rat's nest of cables. So these guys are really friendly, really easy to use. They come in all kinds of form factors. An Arduino can drive up to 60 of them, which is really impressive because they don't consume a whole lot of wattage. Anyway, let's take some RGB LEDs, take some of this. This is one of those pictures where you're like, can you figure out what it is? So this is actually the edge of a piece of foam core board. Foam core board is kind of the way I prototype before I either do 3D printing or laser cutting. In this case, working with foam core board, if you're going to try to prototyping your own stuff after this, which hopefully if you're inspired to try to do some real-time Internet of Things, I recommend this guy. It's a hot edge. An X-Acto knife itself doesn't cut as well as a hot, like 300-400 degrees, just like butter. Anyway, so those are the different tools I use to make this. This is TicTacToe. I call it TicTacToe because, well, it looks like a tic-tac-toe board. I'm going to go ahead and plug it in here. And then it's going to take a second, and hopefully it's going to log on to the wireless. I have a little sign that I'm looking at the windows for. It blinks a little LED pattern when it has connected. And if it does or does not connect, we'll see. If you want to play along, you can go to that URL, and you can actually go ahead and send lights to this guy if he decides to come online. He's not looking real happy right now. Come on, buddy. That Linux system on a chip sometimes takes a long time to boot. Give him just a second more. And all failed. Hit the reset button. Survey says, we shall see. Well, if it doesn't come online, which would be a real bummer, we can go to this URL. And, oh, you guys are already playing with it. Look at that. See WebSocket in action. I haven't load tested this guy. There you go. So those are the colors that you guys are selecting. They're going across all your different screens, and they're going off to the device as well. All thanks, there's an Arduino Yoon in there. It's got those RGB LEDs in there. It's effectively listening in a WebSocket real-time solution to produce those colors. Nice. I wrote that stomp implementation from scratch for the Arduino Yoon, so there was no libraries for it. So glad to see it held up. So that's my TicTacToe. I thought it'd be cool, like long term, to be able to take that and be able to have, say, have somebody in the audience push a button and then have the computer, some other computer somewhere else, like maybe like Watson or something like that, to go ahead and reply and play TicTacToe with Watson in real time, the physical board in front of interesting AI. So what happens here is there's a canvas-based color picker. That's what you're actually clicking on to change the colors. When you click on a color, the RGB value of that pixel is taken, thrown across the Kaazing gateway and distributed via ActiveMQ. In this case, via Stomp protocol again, which I mentioned, which is nice, just a really easy protocol to implement, over to the Arduino, and then the Arduino controls the pixels, and off you go. Are you guys still pressing buttons? Look at you go. Fantastic. I always wonder how to get audiences kind of involved in the conversation, so that's great to see. So I'm going to step it down a little bit. I'm going to take the wireless board off of the Arduino, and instead I'm just going to go with the Arduino. So this is an Arduino Uno, R3. This is a compass module. And it's not just any compass. When you deal with compasses, you have to be careful because, like, if you ever try to balance a needle, a magnetized needle on something, and if you move, what happens to the needle? It jostles, right? So that throws off its accuracy. So this actually has a magnetometer in it as well, so that you can tilt the chip in any which way, and it knows which way is up and can do the math to calibrate back onto the direction that you're actually pointing. And then also happens to have an accelerometer to help it with that math. So I get full tilt access, and I get the compass heading as well. Nice little chip. That I'm going to pair with this guy, which is a Bluetooth. A Bluetooth module. This guy is, I soldered both these guys onto the board and just kind of slapped them on an Uno here. So these guys are sitting on the board. I'm going to power this one through 9 volt because it works much better when you move it around. So these guys are sitting there waiting for a connection. Now what's going to happen is I'm going to take my laptop here, and this guy is paired with my laptop. So I'm going to go ahead and start sucking that data off of the compass in via Java in this case, which is going to access the Bluetooth data, and then it's going to spit that out over the Kaazing gateway. Some of it's going to go off to a MongoDB and get stored, and some of it's going to be rendered on the screen, in this case using SVG again for the gauges. SVG, one of those technologies I think we look back and we say, oh, SVG, who does that? It's old. Nobody supports it. But it turns out today's browsers support it really well. If you're looking at doing rendering like this, SVG is a really good solution. Tween Light for animation, I could go on and on about the ailments of CSS animations and transitions as a specification, but I won't. I'll just top it off with some Tom Cruise. So example here, let me go ahead and start sucking this data in. Oh, it's not going to pair on me. The pairing of Bluetooth. Oh, no worries. Go into my Bluetooth here. Let's see how many of you have Bluetooth devices out there. Jay Chris does. Where's mine? What? What do you mean, no? Ah, live demos, nothing like it. There we go. There it is, Kabloo. So we'll go ahead and connect to Kabloo here. Sorry, so I paired it with my laptop, and now Java can pick it up off of the system. But it is not. All right, you guys, light's going away, sorry. It's, Java's thinking it's the wrong serial port. Come on. There it is, all right, so cool. So now, this guy is in here, and as the compass turns, or as in this case, this is front, so if I pitch down, you'll see that it's gonna drop down. If I pitch up, it's going to pitch up. And again, anybody looking at this on the web can actually see it. Come on, pitch up, pitch up. I'm going to do some tilt. Any pilots in the room? I'm a pilot myself. So I draw a lot of inspiration from this stuff. You can see the compass. As I turn the compass, it's going to get updated as well. This is being pushed over my phone's hotspot, so it's not quite as optimal as a decent network would be, but you definitely get the idea of what that looks like. And there's also a little switch on the bottom to control the light that's on board that we on or off. And because I'm a kid of the 80s, I added my own little Easter egg. All right, anyway. So there's a kind of a basic data telemetry. And I use that aircraft background for a specific purpose. Maybe you stop by our booth down in the exhibit hall. I've seen the quadcopter sitting there. So one of the questions that was raised at Kaazing headquarters is that, well, if we can do real-time data, and how is it that in today's modern age, we lost an aircraft with the Malaysia flight? So wouldn't it be great to be able to collect data off of all the aircraft in real time? How much data would that be? Would it even be feasible and things like that? To collect all the data in real time, GPS coordinates, altitude, pitch, engine status, all those different things, and broadcast them to a base station, make them available. And if you think about, like, have you ever done any kind of travel? Anybody do travel applications here? Like, you deal with like Sabre, like really old, horrible systems. Like, why couldn't that be more modernized? Why couldn't we, rather than having your TripIt look via request response against an old mainframe system, why couldn't it get that data pushed to it real time? So it's interesting, different ways to think about it. But we wanted to see if we could emulate what an onboard kind of black box-ish scenario would be. In order to transmit data over long distances, Wi-Fi itself is not going to be very good. This is an XB. An XB is a 802.15, not 802.11, 802.15, which is just a slight cousin of Wi-Fi designed for low power usage, but for huge range. This guy's got a mile range on it, so it's good for that. Strapped to a quadcopter, right? There's our UAV, and a number of sensors as well attached to that. And what you end up with is the capability to capture all that data and distribute it anywhere, real time, throughout the world, because of WebSocket, really. What's happening here is that we're going to have XB or RF radios on the quadcopter. It's going to go down from the UAV to the laptop. The laptop's going to run that Java program, suck that data in, send it over the satellite in the sky, right? Because terrestrial use wouldn't be very applicable for an aircraft flying across the country or across the ocean or what have you. So we're going to send that off to an MRSAT wireless satellite wireless system, and that's going to go onto the web, where then it gets distributed via real-time architectures like the ones that Frank was talking about. Some of that data is going to get storage. Other pieces of the data get pushed to the UI, and that gives us about 1 second from the UAV anywhere in the world to a UI anywhere in the world. That's the power of WebSocket at your fingertips. And when you start playing with these different sensors, the YouTube is there. The YouTube is embedded there for you to look at on your own if you want to follow these slides later on. But as it turns out, I have it local as well. And I won't show the whole thing, but I want to give you an idea of what it looks like. Turn down my audio here. Yeah, so that'll work. So I'm gonna show you the different parts of the unit, and then we're gonna take off. And so here we are taking off. We're flying around. There we go. So this is the UAV, the drone, the quadcopter sitting there or flying around in the air. All the data is going off real time. So this is a browser. Again, keep in mind that WebSocket capability is delivering all that data real time. It's also going over Inmarsat satellite response. So it's going anywhere in the world in less than a second. That's our lag, rough lag. The data is coming off of it is about 30 points of data, and it gets updated every three times every second. Frank talked about WebSocket and kind of how maybe HTTP as a request response mechanism isn't necessarily suited for IoT. I think this kind of shows you what that looks like in a more practical sense. So there is the telemetry redux. So I show you this guy. This is just a little test unit, example unit, but that's the real deal with the full stack of sensors on it. We put a GPS on the Arduino, the XB data. We put a temperature and humidity sensor on there, put all kinds of different things on there to be able to track all kinds of simulated data that would normally come from an aircraft. So remember that, again, the IoT or hardware in the web equals unicorns. Okay, if there's one thing I want you to take away from today, wait, that's not it. That's one aspect of it. If you want to know anything about any of this stuff, put the slides online. But there's my Twitter handle, Hoyt. I'm happy to answer any kind of hardware questions. Anybody going down this path want to explore real-time IoT hardware, Arduino, feel free to drop me a line on Twitter as well. Frank, did you want to close with anything?
Any questions?
Yeah. Any questions about anything I just showed you? Get out of town.
It's time for a coffee break.
We have a couple questions. I see one over here. Well, so I think when it comes to IoT, so the question is around request response not necessarily being right for IoT. Is TCP right for IoT? I think it's a valid question. I think at this point, all the kind of connected IoT devices I've seen are all been request response. The problem with that is the load it puts on the system to power up, cycle through that data, and use such a heavy exchange. TCP seems to be fine in the devices that I've played with. UDP may be better. Other options, I think, possibly. And even then, again, that's one of the challenges of trying to make it web-enabled, right? So Frank, in his diagram, he showed this whole row of different things that weren't web-enabled devices coming into, in a different architecture than we use today, comes into a central point or an aggregate point where it can be then captured via the web and transferred into data that's more friendly for the web and for other, maybe storage in a database and what have you. So I don't know, to the question, is TCP right? If request response isn't, well, I think there's one over the other, right? I think you can get rid of the request response and work with TCP first, and we'll figure out, then maybe take another step and figure out if that's right. But again, I think depending on the device, like it might be a 433 megahertz Oregon Scientific sensor, for example. Getting that data into the system and making it available on the web is really the big challenge. So there's a few perspectives on it. I think there's a gentleman over here. I'm sorry? Oh. Yeah, so the scalability, so I think Frank has better knowledge of the specific numbers here. But so one of the kind of misnomers you hear is that, maintaining a socket isn't scalable. And that's something that maybe used to be true before we had things like NIO. But nowadays, you can get a far greater degree of scalability. In fact, you can actually get better load from your systems off of a socket connection than you can off of request response these days, if done right and implemented correctly. Is that about right?
Right. No, that's about right. I mean, obviously, it's lighter weight than using HTTP, but I think a better answer is that there's probably 100 implementations of WebSocket. Some of them are going to be more scalable than others. So it's not how scalable is WebSocket. How scalable is that implementation of WebSocket is a better question, in my opinion. Well, they all vary, right? Each implementation varies. I mean, obviously, our company's in business to show that we have the best one, and we can tell you why, but I mean, offline. But you just have to pick one, whatever is good. You know, you pick out of the 100, there are going to be varying degrees of scalability.
And I think scalability is a really good question when it comes to IoT, right? If you say, like, I think Gartner said that every American will have roughly 3 to 9 devices attached to themselves at any point in time in the future, in the not too distant future. So if you think you have enough problems with consumers hitting your website and being able to scale out for just straight consumer request response, imagine multiplying that almost overnight by 3 at least, and then having to do it real time because batch isn't going to bring you the competitive advantage you need. So you need to do all that real time, and you get a real problem. So IoT and scalability is a really good question, and when it comes to the implementation, it really does matter. I think there was another question here as well. Okay, scalability, yeah. Yeah, but you're not going to have. So what you're going to have is in certain implementations, I should say, you're not going to have connection reuse, for example, and that's going to definitely produce a problem for you. If you have systems that are taking in socket connections and the system tops off in number of sockets, then you're going to have a problem. But with things like in I/O and other types of reusing of the socket, what you can actually do is have a single channel by which those sockets can be addressed and without having to have all the open connection, I don't know how to phrase it.
Yeah, multiplexing, right?
Yeah, multiplexing, there you go.
Right, it's just like, you know, if Kevin wrote, you know, WebSocket server, I wrote a WebSocket, like, he can build a fantastic WebSocket server, not in mine. I'm creating a thread per and process per, and it's going to suck. So it's the implementation of the WebSocket server. Some people might be using a really bad implementation of WebSocket, and some people might be using, you know, some async I/O kernel driver, blah 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 blah. That's super fast, right?
Yeah. If I wrote my own, I wouldn't know anything about multiplexing, right? So my implementation will only get so far. Yeah. Good question. Is there any other questions before we close it up? All right. So there is a break after here. Oh, one other question. Sorry.
So that's more of a business question, and then we can talk about that offline. I could certainly answer that, but I'd rather keep it more tech question. Yeah, there's plenty of very good open source implementations. If you want to build like a little chat system that has, you know, like a dozen people, don't use our stuff. Use open source, you know, some small. We're designed for the heavy lifting, you know, enterprise scale stuff.
Yeah, so like on an IoT perspective, right? If you have washer and dryers, kitchens, stovetops, and refrigerators, all the items in the refrigerator, and your GE, and you have all those devices pouring into your network now from all the countless homes in the US, right? Then you've got a scale problem that isn't going to be handled by just your run-of-the-mill implementation, right? Like Frank said, you need chat for a dozen people. That's a different story. All right. Well, so thank you again for your time. Thanks for attending our session. There is a break, so we'll be around.
Yeah. Thank you.